Okay, good evening, everybody. Okay, so today we will continue the lesson on Archimedes principle. Okay, I just write down here. Archimedes principle. Okay, now for your information, this session will also be recorded and then I'll share it in a group again, just in case that you want to refer back. And the previous lesson, I've recorded down, but still haven't posted in the group. Later I'll post it in, right? Okay, now buoyancy. So 今天我们讲到 buoyancy， 可以拿出你们的 writing pad, anything that you want to write down. Okay, prepare. And we are about to start now. Okay, so Archimedes principle before 在我们讲到 Archimedes principle 之前，我们先understand 什么是buoyancy or buoyancy effect. Okay, so what is buoyancy? Now let's say we start with an example. Okay, let's say 我有一个 spring balance and it's hanging an object. Okay, let's say I'm hanging this object in air, right? So whatever reading shown on the spring balance, 10 N, it is the actual weight, right? Actual weight of the object, right? Now, what if I immerse this one in water? What will you see? This one, let's say I put it in a beaker of water, completely immerse it. Okay, what will you see on the reading scale? You'll notice that the reading scale, it reduced down. Okay, let's say for example it becomes 6 Newton. All right, so 6 Newton when the object is in water, this is the apparent weight of the object. Okay, we call it the apparent weight. Now, apparent weight is not equal to actual weight. Is what the weight appears to be provided in that current situation, right? So this is the apparent weight. Now, maybe you wonder why is there a reduction in the weight? Okay, it is because of the buoyancy. It is because of the buoyant force. Okay, now any object 你放什么 object 都好是 immersed in water, there will be a buoyant force acting upward. Okay, so 如果我 label 那个 force on the diagram, this one, the blue force. Okay, so it's acting up, and we label it as let's say buoyant force, so F sub B. Okay, now 我们先画那个 free force diagram 出来先。Okay, now before 你放进水 it looks like this. 这个是 object, and this is the weight, right? And then you have a string. Okay, so when you have a string, then there is tension. Okay, so in this case, the tension is equals to the weight of the object. Okay, so whatever reading shown on the spring balance, you are looking at this tension here. This tension is the reading shown on the spring balance, right? So you are looking at the actual weight. Now, let's say you already immerse it in the water, right? So how does the force diagram looks like? Let me draw it up here. The object, and this is the weight. So you have first the tension, and second you have an additional force, and this is the buoyant force. So you'll notice that this one, the buoyant force, share the weight with the tension. All right, so it share the weight with the tension, so that makes the tension becomes lesser. Okay, so the tension becomes lesser since the tension is the reading that you see in the spring balance, and the tension becomes lesser, which is why that explains why you will see the reading on spring balance will be reduced. All right, simply because the weight is aided by the buoyant force. Okay, now from here 我可以写 T 加 buoyant force 等于 the weight of the object, and then I move the equation, buoyant force equals to W minus T, right? W minus T. So there is like the actual weight of the object, which is 10N minus the tension 6N equals to 4 Newton. Okay, so in conclusion lah, right, to conclude this whole thing, right, the buoyant force is equals to the reduction in the mass, in the weight. Okay, now let's continue. Now, where does the another way to look at what is buoyant force is when you are swimming. Okay, 你游泳的时候呢，你会感觉到你的身体比较轻，就是因为 buoyant force is acting on your body, right? 当你从那个 swimming pool 出来的时候哦，你会觉得你的身体越来越重。Okay, when you lift yourself upright out of the swimming pool, right, you feel that you get heavier and heavier. Okay, it feels very difficult to lift yourself from the water out of the water, right? Okay, it is because the buoyant force is reducing as you lift up your body. Okay, as your body leaves the surface of the water, your buoyant force is getting lesser and lesser, and your actual weight slowly picks up, which is why you feel your body weight your body weight increases. All right, so it is the same concept. Whatever any object immersed in the water will experience a buoyant force. Now, not only water 不一定是水的，因为我们已经讲了 fluid 可以是空气，也可以是水，对不对？所以 buoyant force 也是会发生在空气。等下我会给你一个 example. Okay, the buoyant force in air. But for now, we only focus on water first. All right. Now, let's continue with where does the buoyant force come from? Okay. So where does the buoyant force come from? Now let's understand the physics behind the buoyant force. Let me draw a simple diagram here. Now let's say I have a container. Okay, very long container like this, and the container is filled. Okay, let me draw it again. It's filled with water. Okay, let's use blue color. Water. Okay, now imagine if I put a cube inside. Cube inside. This is the cube. Now, let's recall back what we learned about the pressure in liquids. What do we understand about the pressure in liquids? First thing, pressure in liquids acts in all direction, right? Right? So all direction meaning that the pressure is acting on this wall, acting on the object here, left, right, top, down, bottom, all these places. Pressure is acting. Right? This is the first point. Now, second, the pressure in liquid increases when the depth increases, right? When it gets deeper, the pressure increases. Now, let's pick 4 points on the object. Let's say this object, I label point A, and then point B. On the right side is point B, and point C is on top, and point D is at the bottom. Now, 我们先看 A 跟 B。Point A and point B 哦，因为它们是同样深度啊 ，the depth is the same， 所以 any pressure acting on point A is the same as any pressure acting on point B, right? Because they have the same depth. So I write down PA equals to PB, right? Now let's look at point C and point D. Point D is deeper, right? So pressure at D, by theory, it should be greater than the pressure at C. Now, what happens when you have this difference in pressure? Remember, I talked about in the first pressure lesson, I talked about when there is a difference between pressure, there will be a force, a resultant force, going from the high pressure to the low pressure, right? So where is the resultant force going? Here, from the D. Okay, you see the blue arrow here? I label out. So this is the resultant force, okay? Because pressure D is higher. Now, let's find out what is this resultant force. What does this resultant force represent? Okay, can we use a mathematical equation to find out? Okay, now, resultant force. Okay, 首先我先 label 这个 PD 先。PD pressure at point D equals to what? Okay, we use the formula for pressure. Okay, PD is equals to force over area, right? So force at D divided by the area, and PC will be equals to the force at C divided by the area. Okay, now let's express the formula in terms of force. FD 等于 PD 乘 A， 然后 FC 等于 PC 乘 A。OK， 所以你有这个两个 two forces 啊。Now force at D is bigger， 因为 pressure at D is bigger, right? So force D is bigger. So when we calculate the resultant force, we take the bigger minus the smaller one. Okay, always the bigger minus the smaller one. So FR equals to FD 减 FC. All right, so I put in the formula. So this one, PD over A minus PC A. Okay, now cross section area 是一样的嘛，因为 it's the same object, right? The top and the bottom they have the same area, so I just factorize out. So PD minus PC A. Okay, now 现在我们看哦，这个 PD 减 PC 啊，我们现在 substitute 这个 PD. What is the equation of pressure for water? Do you still remember? I write it on top here. P 等于 H rho G, right? It depends on the height, the density, and the gravitational constant. So I put it inside. So this is like HD rho G minus HC rho G, and then A. Okay, so slowly we are going there. We are going there. So here you have HD minus HC. 因为 rho 跟 G 是一样的嘛，所以我也是可以 factorize 去外面，所以 rho G A. Okay, now this HD minus HC 啊，我可以直接写成 the change of the height. Alright, I write it as the change of height. This one simply means that I'm using the height, the bottom height minus the top height. Okay, now from this formula here, change of height multiplied by this one area, what do you get? Okay, if you look at, I draw a simple diagram here. Okay, this is the, 哎呀，没有地方给我画，给我画在上面这边一点。Okay, let's say this is your cube, this is your cube, and the bottom section, this one is the area, right? This is the area. So the area multiplied by the change of height. This is the height over here. Okay, you see what I label here. So on top is point C, right? And at the bottom is point D. So when you have area, the bottom area multiplied by the height, what do you get? You get the volume. Okay, you get the volume of what? The volume of the object, of volume of this cube. Okay, so this one, change of H times A, we can just write volume. We cancel out this. All right, so rho, volume, and G. This is the resultant force. FR equals to FR equals to rho VG. Now, 这个 resultant force 我们可以直接把它写成 what is it? The buoyant force. Okay, 所以你放 any object in the water, there will be a buoyant force, and this buoyant force depends on, when you look at the formula, right? It depends on, first is the density. 哎呀，一下按错了。Okay, the buoyant force, first it depends on the density of the liquid that the object is in, and then it depends on this one, the volume. Now this one have to be careful. 你要注意这个 volume， 这个 volume 是 volume of the submerged section. OK， 在这个情况下呢，这个 example 是这个 object 啊，这个 cube 啊是整个 immersed in the liquid, right? So if it's completely immersed in the liquid, then this volume is equals to the volume of the solid. Okay, sometimes it can be halfway immersed, not completely, like partially immersed. Okay, so have to be careful. If it is partially immersed, then this volume, it does not equals to the volume of the solid. Okay, it simply is the volume of the immerged section. All right, remember this, right? So the buoyant force depends on all these three. Now, let's talk a little bit about the buoyant force. Now, if you want to screenshot, you can just take a snap first. 因为我要擦掉这个，然后继续讲，不够威给我。Okay, you can take a snapshot, or never mind, I also record this down lah. Okay, excuse me. So from here, so far 我们知道 buoyant force 等于 density, volume, and 这个 right? Now, so if you look at the definition of the buoyant force, you can see it in your textbook or reference book. Buoyant force is an upward force. Okay, I write down. Buoyant force, just a quick, is an upward force resulting from an object being wholly or partially immersed in a liquid. Okay, so if you look at the definition of the buoyant force, it says that it is an upward force resulting from an object being wholly or partially immersed, meaning that sometimes doesn't matter it is completely immersed or just halfway immersed, there is still buoyant force. All right, this is what it means. Right, now this buoyant force depends on two things, right? The density and the volume. Now let's look at the volume first. If the volume is high, okay, let me use a different color. 如果那个 volume of the submerged section is high, then my buoyant force is high. How do I know this? You look at the design of ships. Okay, 那种船的身体很大的嘛，对不对？ And it's sometimes hollow inside, right? It's air, right? This one, the hull of the ship. Okay, why it has to make so big? Because it simply wants to increase the volume of the submerged section. Okay, so this is the ship, and this is the water, right? So where is the submerged section? It's down here, right here. This is the volume. Okay, so the bigger the volume, the bigger the buoyant force. So what happened? Why do we want a big buoyant force? Because if we have a big buoyant force, then we can balance out the weight of the ship, and that's when it floats, right? Okay, same thing as the density. When the density of the water increases, okay, the density here increases, the buoyant force also increases. So you look at like river and seawater. Seawater is more salty, right? It's more salty, meaning that it has higher density. Okay, so you swim in the seawater, then meaning that you get a much greater buoyant force. Okay, you don't sink easily compared to when you swim in the river. All right, so if you look at this one, actually there's one place. Last time I read about the article, right? They said that, have you ever heard of the Dead Sea? The Dead Sea. 它这个是一个地方在 Israel. Okay, 它就很像一个yeah, as the name suggests, a sea lah. Okay, in Israel, and this one is the most salty. They said the highest salinity. Okay, the highest, they have the highest salt content. They have the highest salt concentration. Okay, and they have very high density. This sea is very high density, meaning that they say that if you swim in the Dead Sea, right, you won't sink one. Okay, 你不会给淹死。如果你在那边游泳，你不会游泳，你都不会给淹死，就是因为它本身的那个density 已经是很高，所以它的 buoyant force 很高，所以你不会沉。Alright, this is they call the Dead Sea. 可是他们讲是不会淹死，也不完全正确啦，因为你想下，如果你的身体掉转了 ，let's say 啦 ，OK，let's say 你是躺在那个水上 ，OK， 你不容易沉的嘛，对不对？可是 imagine 如果你的身体掉转了，你的脸是在那个水下面 ，OK， 有时候你会很难要 翻身啊，你会很难要翻回你的身体。为什么？因为你要翻回你的身体的时候呢，你的脚一定要 push downward 嘛 ，right? You have to push downward, inward the inward into the water. Then only then you can lift up your head, right? So because of the buoyant force is very high, right? It makes you very difficult to turn your body, right? It makes you very difficult to turn your body or to push your leg downward to lift up your head, right? So this incident really happened, I think, a few years ago. Okay, really happened. There's one woman, I think around 80 years old. Okay, 80 years old woman actually died in this Dead Sea, right? So you could die also. It depends lah. It depends lah. But theoretically you won't sink lah because of the salinity. And the scientist said 你不可以在那个水里面 for 好像超过10分钟。为什么？因为它的 salinity 太高是，它会影响你的皮肤。OK， 皮肤它会弄你容易什么容易弄你的皮肤变 soft 然后会容易割伤。And there's many more lah. There's many more reason. There's many more reason why you cannot be in it for too long. Right? So the same thing. So the point is, the higher the density of the water, the higher the buoyant force. Right? The higher the buoyant force. Okay. Let's continue. Now, take back the previous example. This one, right? My spring balance, hanging my object, and it reads 10 Newton, let's say. Now, if I put it in water and it reads the weight decrease, say 6 Newton, right? 6 Newton. And the buoyant force acting, if I draw it out here, FB is 4 Newton. Now, what happened if I cut the string? Will it sink or float if I cut the string? Okay, so if you look at the free force diagram, this one is the object, this is the weight, this is the tension, this is the buoyant force. If I cut the rope, I cut the string, meaning that my tension is gone. My tension is gone, my buoyant force is only 4 Newton. The weight is 10 Newton. So it is not enough to withstand the weight. So as a result, what happened is that the object sinks to the bottom. All right? The object sinks to the bottom. Why? Because the buoyant force is less than the weight. Okay, notice my statement here. The buoyant force is less than the weight. Okay, so when the buoyant force, first one, when the weight is greater than the buoyant force, object sinks. Okay, so you draw a diagram here. Weight, buoyant force. This is sinking. Second, when the weight is equal to the buoyant force, object floats. All right, object floats. Now, floating can be in several like, okay, 我说来给你看. Floating can be like this. First one, this is the object, okay, and the object stays at the same height like this. Okay, it won't sink, it won't go down, it won't go up. Okay, this is we call floating. As long as it is hovering, as long as it is hovering at that exact position. Okay, now this is like partially immersed, right? 只是震到一半罢了嘛. Okay, and sometimes it can be like this. This one, if the object is completely immersed in the water, but it is not moving down and it is not moving up, it just hovering at this position. This one we also consider it as floating. All right. This one we also consider it as floating. And the third one, it can be like this also. This is the water. This is the object, and like in line, the top of the surface of the object is in line with the surface of the water. This one is also considered floating, as long as the object is hovering at that same position, then we call it floating. OK， 不是讲那个 object 一沉进那个 surface of the water 啊，就是沉了啦，不是这样子讲啊。OK， 是看它的 movement 是怎样。If it is moving down, then only we consider it sink. All right. So it can be, this one is, we call it partially immersed. The first one, this is partially immersed, and this is wholly immersed, right? Wholly immersed. So floating can be partially or wholly immersed. Now the third scenario is when we have the wave is less than the buoyant force. Okay, so it looks like this. Buoyant force is longer, wave is shorter. So this one, object rises. So this is called, we say that rising. Rising. Okay, so three different scenarios. Either it floats, or it sinks, or it rises. Now rises is different with floating 啊，也是不同的。Rising 就是很像那个 object 啊 ，let's say I draw it out, the object is like completely on top of the surface of the water. Okay, completely on top. If you look at down here, 我画在下面这边中间。Okay, this is the cube, and it is completely lying on top of the surface. This one we consider it rising. 如果你看到它的这个 object 啊，好像有一点点是已经在那个水的下面是，那个我们已经叫是 floating 了。Okay, that is we consider floating. Okay, so for rising, there's no submerged region. Okay, so this is the three different scenarios. So you want to take a screenshot, you take a screenshot, and then I want to go to the next page. OK， now 现在我们才看 Archimedes principle 到底在讲什么。OK， so if I just quickly type out the definition, Archimedes principle, it is talking about what? Okay, it states that OK， 看这个 definition of Archimedes principle. So Archimedes principle states that for a body wholly or partially immersed, okay, the upward buoyant force acting on it is equal. This one is equal to the weight of the liquid it displaces. 什么鬼意思? Okay, let's look at example. Okay, let's say I'm doing an experiment. This is the Eureka can. You know a Eureka can? It's like they have the opening here to allow the water to flow outward. Okay, let's say this is the wooden block, and I put a beaker down here. Okay, now this is the water. So the water is filled up at the opening here, in line with this. Let's say I'm hanging one object. If I lower this object down in the water, it displaces some of the water, right? It forces some of the water to flow out of the Eureka can here. So the water will flow down here and down here. Okay. Now, Archimedes principles 哦，他在讲着 the buoyant force is equal, so FB equals to the weight of liquid or fluid lah, fluid, the weight of the fluid displaced. Okay, so if you completely immerse this object in the water, it will displace a volume of liquid. Okay, that is the same as the volume of the object, right? If you completely immerse it, the volume of the liquid coming out is equal to the volume of the object because of the spatial volume that is missing, right? So the buoyant force of, okay, I repeat, if you lower this one inside, so the buoyant force acting on the object, it will be equal to the weight of the liquid displaced. So meaning that if you take this beaker and you measure the weight, it will equal to the buoyant force acting on it. All right? So that tells us that FB 等于 weight of the water, weight of, I just write WL lah, okay? Weight of the liquid displaced, and it is also equal to rho Vg. Right? Rho Vg. Remember this one. This is very important, this formula. It's like this whole chapter, you just use this one. Okay? The buoyant force equals the weight of water displaced, and it is equals to rho Vg. Okay? Now, 还有一个我要提醒你们的就是一个 object 是它可以是 partially， 然后它可以是 wholly immersed, right? So this section here, I shade this section. This is the immersed section. This is the immersed section. Okay, 先看第一个，这个 partially immersed 哦，意思是说我的 volume， 当你算这个 FB equals to rho Vg 的时候啊，这个 volume 是 the volume of the submerged section 哦 ，OK， 所以这个 Vs 是不 equal to the volume of object. I just have to remind you, okay? I know you know, but I just have to remind you again, right? So for this one, same, okay, this one is wholly immersed, right? Wholly immersed, so FB 等于 rho V VSG. So this one, since it is wholly immersed, meaning that my volume of object equals to the volume of object, right? These two things. Okay, now let's look at the next part. So how do we determine whether an object floats or not? How to determine if an object floats? Okay, you already know that. How to determine if an object floats? We know that an object floats when, for an object to float, the buoyant force must be equal to the weight of the object, right? And since the buoyant force is equal to the weight of water displaced, right? This one is my Archimedes principle, right? Since the FB is equal to weight of water displaced, then the weight of water displaced it must be equal to the weight of the object. Okay, 所以如果你的 water display 是等于你的 weight of the object, then the object will float. Okay, now 我剩下几秒在这边，我要在这边停先，我再 send 那个 link， 然后你们再进来，因为等下我整个东西会不见掉，所以我要重新写过。Okay, I left 1 minute here, so everybody log out and log back in.